Welcome to Industry 4.TV. This is our first edition of the IIoT Live. So this is where we're going to be talking about the different tools and the different solutions and architectures that you need to build your industrial IoT solutions. So I see we've got participants joining. If you would please let me know where you're joining from. Okay, so in this edition, we're going to be discussing MQTT Sparkplug, the architecture, design, and operational behavior. So basically, the idea here is to introduce you to MQTT Sparkplug. So I know I've been putting out a lot of content around MQTT and Sparkplug, but I thought this would be a perfect opportunity to kind of like put together a back to basics to start by introducing you on what Sparkplug is, particularly focusing on the network architecture and also the operational behavior of the involved components on Sparkplug. So I can see a lot of familiar faces here. So thank you so much for joining in on the session. So again, this is a new edition. So I would like to get some feedback from you on what is some of the topics that you'd want me to cover going forward. I've got a lot of guests who are going to be joining these sessions. I've got a lot of topics lined up, but I'd also love to hear from you what it is that you'd want to learn in this session. So this is an interactive session. Feel free to put some questions in the comments. I'll get to those as I present here, and also put in some suggestions for the topics that we can cover in the upcoming sessions. And also, can you please let me know if I'm audible and visible? Just let me know in the comment section here, and then we can get started. Okay, can you please let me know, just put it in the comments, let me know if I'm audible and visible, and then we can get started with our session. Nice, thank you. Okay, so I'll share my screen here. So today we're going to cover 4 main parts here. So that would be the introduction to MQTT Sparkplug, and then I'll also take you through the Sparkplug architecture. And I'll also kind of like show you like a real Sparkplug device so that you can get a sense of what it feels like to work with a Sparkplug device. And then after that, we're going to go through the different operational behaviors. So I'll go ahead and share the slides that I have here. So again, this is going to be a session on MQTT Sparkplug, architecture, design, and operational behaviors. So now my assumption here is that most of you here on this call are pretty familiar with MQTT, but nonetheless, we're just going to take a few moments here to kind of like really talk about what MQTT is, which will allow us to really build a foundation as we kind of like discuss going forward. And it also going to help to make the case as to where Sparkplug kind of like fits into the picture. So basically, MQTT is a publish subscribe communication protocol. So as opposed to some traditional protocols in industry that work in a request response kind of communicating pattern, for example, Modbus TCP, where you've got the master layer or you've got the client server, you've got these two components directly connected to each other, sending request messages and response messages. With MQTT, what you introduce is a middleman, which is like a broker in the middle that takes care of handling the communication and distributing the messages to all participants. So you've got subscribers, and then you've got publishers. So publishers publish messages to the broker, and they use an MQTT topic to kind of like use that as an identifier to say this is the bucket of information where you can find a certain piece of data that you're interested in. And the subscribers, if they're interested in a certain piece of information, they subscribe to receive that information. So this kind of like creates a hub and spoke model, a fan-out architecture that allows you to plug many different components and system. And obvious advantage here is that you can easily scale such a system. And also you've got a decoupled architecture that allows you to interchange these components, because as you can see on this a slide here, you've got your industrial software and hardware here. If all of those are communicating using MQTT, all they need to understand is the MQTT protocol. It doesn't matter what protocol the PLC is communicating natively. If it understands MQTT, it can simply subscribe to the broker and it will receive all the information coming from the different applications. So that is MQTT generalized and simplified in a nutshell. But again, the focus of this presentation today is more on Sparkplug. So to kind of like set the stage here, let's talk about what the limitations of MQTT are as far as the industrial IoT applications is concerned. So again, as you would know, with MQTT, you use an MQTT topic hierarchy to kind of like identify the source of the data, right? Now, that is a flexible way of building IoT applications only if you're operating in a constrained environment. So for example, if you are building a home automation system and you've got like a fixed location, to say you've got your house as the top level hierarchy, and then you've got your, say, living room as the second level hierarchy, and your network is only concerned about participants that are within your room. So you can use MQTT, flat MQTT for that, because there's no need for you to interact with other systems that are outside of your household. So that's a flexible way of doing that, because it means that you can apply it in many different domains. But when it comes to industrial IoT, it becomes a problem, because we need to know exactly what is the source of this information. Because in an industrial setup, you've got your production line, you've got all your equipment. If you want to interact with that equipment or all these systems, you want to have a way of knowing where the information is originating from. So you can't have a situation whereby everyone is choosing their own topic structure to represent the source of the messages. The other problem with flat MQTT when it comes to industrial IoT implementation is that there's no consistency in the state management, session state management. So what do we mean by that? In a SCADA environment, the SCADA always wants to know what is the state of a component that is participating in a network, right? So if the component is online, the SCADA needs to know. And in traditional architectures, the SCADA uses a poll mechanism by frequently sending messages to the component to get a sense of that real-time connection. So the only way it can know that a component is still alive is by sending a message and receiving a response. So it knows that the state of this component is online, but it has to keep on sending so to that to get a sense of that state, right? So MQTT has what is called a death certificate, right, built into the specification, but it is not enforced in a way that it is consistently available to all devices or systems that use MQTT, right? So that is a problem, because you need to have a consistent way of representing the state of components in an MQTT network. So that is problem number 2 when it comes to the application of MQTT in industrial IoT systems. The third problem is there is no consistency in the representation of data. So what do we mean by that? Now, with flat MQTT, when you send a payload, a message payload, what you're essentially sending is a binary encoded message, right? You don't know whether this is an integer, this is a float, this is a date, this is a time, this is an alarm. You don't know that, right? You are just getting a binary message that you need to decode. So the only way you could use that information in an effective way is by having a way of predetermining or understanding or having some kind of lookup mechanism to say this is an integer based on this information that has been hard-coded by the application programmer. So that is a disadvantage because there is no common data types between components in an MQTT, in a flat MQTT network. So that is crucial to have because you want to have a situation whereby if a PLC sends a message to a SCADA system, the SCADA system needs to already understand that it expects to receive an integer because then it knows how to present an integer. So it's really crucial for that interoperability to be there if MQTT is to be useful within an industrial IoT setup. So these are the three challenges that MQTT or flat MQTT currently is faced with when it comes to its application in an industrial IoT setting. So these basically are the problems that Sparkplug aims to solve. So Sparkplug basically is a specification that aims to solve these three issues, right? How does it do that? First of all, it defines a consistent MQTT topic structure, right? Standardizes on the topic structure such that all participants are forced to use a certain structure when it comes to their topic representation, which makes it easy for you to kind of like represent the source of information within an industrial setup. So if data is coming from a certain corner of your factory floor or from a certain part of a pipeline, you want to be able to know that this is data coming from that specific part. And the only way you can reliably do that is when you have got a standardized way of structuring these and grouping all these sources of your information. So Sparkplug solves that problem by defining that topic structure in a consistent manner. So if a vendor is implementing, say, Sparkplug on their PLC or SCADA system, then they need to adhere to that topic structure so that they can usefully participate within an MQTT Sparkplug network. Now, the second issue that MQTT Sparkplug solves is the issue of state management, right? So to make sure that we don't rely on applications implementing the death certificate, Sparkplug enforces that using what is called NDEATH, right, or DDEATH, which is what we're going to talk about more of later on in this session. But the idea there is that we take the existing death certificate mechanism within MQTT and create a specification on top of it that enforces all participants within an MQTT Sparkplug network to implement, right? So on top of the death certificate that already comes with flat MQTT, Sparkplug goes a step further and introduces the concept of birth certificate. So as you would know, with a death certificate, it's a mechanism whereby an MQTT client, when it connects to an MQTT broker, it publishes a death certificate during that connect message. So the death certificate, basically the idea is that whenever connection is lost unexpectedly with that client, the broker needs to inform all the participants that are subscribed to receive information from that client that this client is no longer online. So that's the concept of death, which already is there within flat MQTT, but Sparkplug introduces now the concept of birth to say when an application joins, it needs to announce again that it has joined the network, and this is the information that it is going to be publishing into the network. So that is also crucial for building systems that are able to anticipate, and also systems that allow you to use like a graphical, a configuration mechanism to build applications, as opposed to really having to hard code all of this stuff. So Sparkplug takes care of that session state management, which also we're going to talk about it when we talk about the behaviors of exactly how that interaction happens under the hood. Now, the third aspect that Sparkplug defines is the consistent representation of data. So basically, what this means is that, first of all, Sparkplug defines data types for metrics, for representing metrics. So if a metric is going to be an integer, that data type is included in that message, so that whoever is consuming that message, or that message that has already been announced during the birth, it contains that data type. You already know that this is an integer, and if a Sparkplug consumer receives that information, it already understands how to interpret integers as far as Sparkplug is concerned. But a key thing to point out here is that there's different levels to data representation or data types within a Sparkplug stack, right? So there is the top level data type definition, which is like your metrics, so your integers, floats, and also what we call templates, which are user-defined types for those of you who are familiar with PLCs and SCADA development, where you're able to kind of like create a structured data type that has got multiple variables within it. So that is the top level metric definition, which needs to be understood by both participants or consumer and publishers of information within an MQTT Sparkplug network, right? And then the second level is the data types that needs to be understood by the programming language. So if, for example, if you're building a gateway using, say, Python, now Python has got its own understanding of what an integer is, which is different from like what a Sparkplug data type would be. So there is that idea of having to use data types within a programming environment. Now that is generated by a protobuf libraries. So the data type that eventually goes under the wire on a TCP IP connection is a protobuf encoding data type. So this is what you use when you're programming to generate those data types for that specific programming environment. And then when you compile that, all of that is then converted into some data types that are then sent as binary messages in an efficient way. And then on the other end, they're then decoded all the way up to a Sparkplug metric that is then understood at application level by whatever application is consuming that information. So that's basically what Sparkplug really adds into on top of MQTT. It's a specification, it's a software specification that vendors need to adhere to whenever they build a Sparkplug compliant system. Now, they never used to be a way of checking compliance, but recently Sparkplug introduced a way of a TCK, a way of checking compliance to say this device truly supports Sparkplug. I remember I'd worked some time before with some devices that they would claim to support Sparkplug, but they don't really tightly integrate within the system. But now there is a way of checking and then having a Sparkplug compliant logo or tag to show that this has been verified, that it follows that Sparkplug specification. Okay, so now when it comes to standardizing the topic namespace, this is the structure that the Sparkplug specification defines for Sparkplug network participants. So the top level is the namespace, followed by the group ID, message type, edge node ID, and then the device ID. Now, the namespace is an indication of what payload encoding mechanism you are using. So there used to be Sparkplug A, which was the earliest version, where you're using a different type of encoding mechanism. So this is where you highlight it. And now we're into Sparkplug B, which is a different way of encoding your payload. So this namespace is where you are specifying. For example, here you can see that we're saying an example is Sparkplug B version 1.0. So it indicates that this is a Sparkplug B encoded payload that you expect to get from this topic namespace, right? So again, I imagine whenever, say, Sparkplug Foundation or the Eclipse Foundation releases, say, support for JSON, I would imagine this is where you're going to indicate that this is a JSON message that is being published on this topic namespace. So that's what the namespace element is for. And then the group ID element is a way of grouping your MQTT edge nodes. So if, for example, like I mentioned earlier on in this call, that you need to have a way of grouping devices in a logical or physical setup, whereby you're saying these groups belong to this specific area of the factory, or these nodes belong to a specific area of a pipeline. So if you need to have a way of grouping these, you use this group ID to indicate what group a specific edge node is located in. Right, and then the third element here is the message type, which is a way of indicating what sort of message is being sent on this particular topic. So I'm going to show you in this next slide the different types of messages that you can fit into this topic namespace. And then this level here is the edge node ID. So Sparkplug has got the concept of edge nodes, right? So which I'm going to show you again also in the architecture layout. The edge nodes are data producers that publish these Sparkplug messages. So you need to have a way of identifying which node. So a node belongs to a group, right? As far as this structure is concerned. And then there's also what are called devices, which typically these are devices that sit behind a gateway. So this would be like a device that maybe doesn't know how to communicate using MQTT. So it will sit behind an edge node or a gateway, and then information is going to be translated on its behalf by the edge node and then pushed up into the MQTT broker. So now let's look at the message type. So there's different message types. So as you can see here, if an edge node is sending a birth message, so as I already mentioned, there's a birth message and then a death message, it has to indicate in the message type whether this is a birth certificate or this is a death certificate. Also, if this the device is sending just a piece of data, it indicates that this is a data that is coming from a node, or this is a piece of data that is coming from a device that is behind a node. So again, there is also concepts of the command, right? So you can also transmit commands over the MQTT Sparkplug network, whereby a host or Sparkplug or a SCADA is sending commands to control or to instruct an edge node to perform some functions, right? So I can see there one user is saying here, I hope you'll be covering the shells method. So unfortunately, I'm not going to be covering the shells method here, but basically, I think we can kind of like really quickly touch up on that to say, because of this topic structure that you see here, we have only got the group ID and the edge node ID and device ID. So basically here you've got three elements with which to represent the hierarchy of your enterprise, right? So, and this is hardly enough to represent the hierarchy of any enterprise. So typically maybe you have your enterprise has got like 6 levels. So maybe within a factory, you've got 6 levels that you want to be able to represent within a topic namespace, so that at least you can have a way of determining where what is the source of the data based on that topic namespace. So basically, there's ways to kind of like go around that, which are captured in what are called the Schultz methods by Dave Schultz, and the Paris method by Matthew Paris, who are part of the Industry 4.0 community. So basically, with the Paris method is that you use delimiters here, right, to try and fit in a lot more hierarchies or levels of a hierarchy within that same topic namespace. So you can use this colon here to indicate that here I've got 2 levels within group ID, or if you've got 3 levels, you can use that to indicate that here I've got 3 levels. So this is a way of a custom way of extending a Sparkplug topic namespace to try and fit in as much levels of hierarchy as possible. And if you don't want to use this method, you can use a shalt method, which is really a way of using multiple brokers to kind of like really propagate levels. So you could have this topic namespace and use it as it is, but then push it onto another high level topic namespace so that it is contained within an enterprise. So again, we're going to touch on the shalt and Paris method in later editions, where we're going to be focusing more on that creation of a unified namespace. But just to kind of like tell you there what the user is really asking about as far as the shalt method is concerned. Okay, so now let's move on to the architecture. So if you've got questions, again, feel free to drop them onto the chat here. Now, these are the components that are involved in a typical Sparkplug architecture. So there's different types of participants in an MQTT Sparkplug network. So there's what are called, or obviously there's the MQTT broker, which is kind of like that component that sits in the middle and does the coordination of messages, sending messages between different components, forwarding messages. Now, the only requirement here for a broker to be able to transmit Sparkplug or to handle Sparkplug messages is that it needs to be at least MQTT version 3.1.1, right? So that's the basic requirement for the MQTT broker. So another component of the MQTT Sparkplug architecture is an edge of network node. So an edge of network node basically it's a device, right? It's a device, or it could be a piece of software, but primarily it's a device that is capable of communicating via MQTT Sparkplug natively. So it means the vendor of that device would have implemented the Sparkplug specification and made it a native part of that device. So meaning that if that device is interfacing with sensors directly and having those variables within the program of that edge of network node, those variables can be exposed to the MQTT broker or published to the MQTT broker as Sparkplug messages. So typically this would be like a gateway, or maybe if you happen to work maybe in a greenfield environment whereby you are installing a new PLC, you're connecting it to sensors, or maybe you're just extending your factory, you're connecting to sensors. So this is where you typically you'd use an edge of network node connected directly to sensors, and all of that information being pushed up to the MQTT broker for consumption by other network participants. So I've got an example of an edge of network node here so that I can kind of like give you an idea of what that looks like for some of you that maybe have not kind of like come across a Sparkplug edge of network node. So here behind me, I think you can see I've got an Opto22 Groove Rio. So it's got a temperature sensor directly connected to it, and it's exposing all of that information via MQTT Sparkplug. So let me see if I can share my screen here to show you what that looks like. Okay, so this is the dashboard of the MQTT of the Opto22 Groove Rio. Just let me know if you can see the screen there. So basically, that's the management interface where you can configure stuff, where you can connect to sensors and all that kind of stuff. So if you see here, if I go into IO channels, I've got some data that I'm actually simulating, so you can see this temperature. So this is from a previous project that I was working on, where I was simulating data for a wind turbine. So as you can see here, I've got turbine speed, wind speed, turbine torque, and then you've got the temperature connected on this. So the temperature is actually coming from a real sensor, which is this one here that I have connected to my device here. So as you can see, if I write it here, you can see the temperature is going up. So these are variables that are available within the I/O system of this particular remote I/O device. And this I/O device happens to be an edge of network node. So it's capable of pushing all of this information to an MQTT broker using report by exception, meaning that the data is only sent when there is a change, right? And if I go into this channel, you can see here, I can actually specify a deadband to say, I only want data to be transmitted after it has changed by, say, more than 1 degree. So if it changes by 0.5 degrees temperature, it doesn't get published. So that's a way of controlling that report by exception, establishing that deadband to say, report by exception only kicks in when it's it has changed by more than 1 degree. So now this is the I/O interface showing you that this is how it is connected. But I want to show you again how typically you'd interact with a Sparkplug edge of network node by configuring it to publish to a specific group or specific broker. So here you can see I can go into MQTT Sparkplug configuration. So typically, this is typically a procedure that you'd have to go through when you're dealing with Sparkplug edge of network nodes, where you're literally just configuring stuff, right? You're not like writing code and embedding it into something. You're configuring stuff by specifying what you need to use as a topic name representation. So here you can see I'm specifying that this is I'm just saying this is a packaging area, right? So that's the group ID, meaning that this specific edge of network node is going to be contained within the packaging area. So whoever is receiving this information can easily identify that this is from a node that is coming from the packaging area. And what is the name of that node? Here you can specify on the edge node ID to say this is line 1. So again, you can customize it to these two, however you want this information to be represented. So this is where you can specify your group ID and edge node ID. And of course, here you can then specify the broker where you want this information to be pushed. So as you can see here, without doing any programming at all, just by configuring my IO module to set a deadband and also making sure that it's publicly accessible, and then configuring information about the broker, and then configuring also information about the group ID, edge node ID, and all that kind of stuff. This information automatically gets pushed to the MQTT broker, and then it's available for consumption by whether it's a SCADA system or it's an application that is consuming this information. So I'll quickly, so here we're actually publishing information live here. So maybe I can quickly also change my screen here to show you. So I've got, okay, so I don't have it here. So I've got an MQTT.fx here, which I kind of like wanted to show you that I'm actually receiving information coming from this device. Okay, it's not here, so that's okay. So basically, that's the way that typically you would interact with an edge of network node within a Sparkplug ecosystem. So now let's go back to our architecture. So that's all about the edge of network node, where you've got a direct interface with sensors pushing that information to an MQTT broker. So now the other type of component that participates within an MQTT Sparkplug network is a device, right? So it's a Sparkplug device. So that would like typically maybe be like a Modbus device. So that is a device that is not capable of communicating via MQTT. So which means that device requires its information or its data to be first converted into an MQTT protocol before it can be published into an MQTT Sparkplug network. So that device will typically sit behind an edge of network node, right? So an edge of network node will take care of polling the device to get that data and then translating that data into an MQTT Sparkplug payload and then pushing it into an MQTT broker. So if you are dealing with a Sparkplug edge of network node, you can then customize what the device ID of each device that is sitting behind an edge of network node is. So now this can be a physical device where you've got like say a Modbus device, a backnet device that you are connected, you have connected via either Ethernet connection to an edge of network node that understands how to read this information and convert it to MQTT Sparkplug, and then has a way of like kind of like segmenting all these devices. Or these devices they don't have to be physical devices. They could be like logical devices, meaning that they could be devices that are defined within a Sparkplug edge of network node. So for example, if you want to have a way, which I'm going to show you shortly here, metrics belong to a device, right, or an edge of network node. So there are situations whereby maybe you've got like thousands of metrics. So you don't want those metrics to be sent under one edge of network node or under one device. You want to have a way of kind of like categorizing them so that at least you have got maybe 10 metrics or 100 metrics per device. You can create those devices in soft, like as logical devices within your edge of network node and allocate the different variables to these so that at least you've got a way of really apportioning your metrics to cater for each device so that you don't have a lot of metrics going coming from one device or one of edge of network node. So the other type of component of a Sparkplug architecture is an application or a host application. So this is an application that is capable of consuming MQTT Sparkplug messages. So this would typically be a historian. So a typical example maybe would be a canary historian that understands how to consume these messages, maybe for the sole purpose of persisting them to a database, or maybe just showing some graphs or creating some trends, or maybe it's an AI system, a machine learning system that understands Sparkplug. There's a few of those that understand Sparkplug, just needs to generate some analytics out of it. So that would be a typical application that is capable of consuming this information. So as you can see, it has got different functionalities to an edge of network node. This one is a Sparkplug application that is built for the sole purpose of consuming this information and maybe displaying it and all that kind of stuff. And then we've got the primary host. So the primary host now is it's otherwise known as a SCADA or IIoT host, meaning that's the device that is capable of even transmitting commands to edge of network nodes. So this is like kind of like the control device that is capable really of controlling other nodes to instruct them to perform some routines. So this is typically is your SCADA system. So maybe it could be ignition system, or it could be an IoT platform or ignition SCADA system, so that you can send commands to devices or some edge of network nodes for them to be able to perform some function, or maybe just for that supervisory mechanism that is typical of any SCADA system. Now, the primary host, it needs to be defined, right? So you can only have one primary host for a certain group of components. So what I mean by that, you can have like more than one, you can have multiple primary hosts, but an edge of network node would only recognize one primary host, right? So it is a primary host from the perspective of an edge of network node. What determines whether an application is a primary host or not? It is an edge of network node, which again, if you go back to this interface here for Opto22 Groove Rio, you can see here that there is an option for specifying the primary host, right? So this is where the edge of network node is then able to specify that this is my primary host. So the primary host is a host from the perspective of an edge of network node. So what that means is that you can have multiple edge of network nodes connected to the same broker, but maybe subscribing or recognizing different prime host as their applications as their primary host. So you can have this edge of network node recognizing this as the primary host, or you could have this edge of network node recognizing this specific primary this application as its primary host. So this kind of like really is to emphasize the point that a primary host is deemed by the edge of network node that it is a primary host. And the reason for that mainly is, for example, if you've got a PLC that is controlling and publishing information back to the SCADA system for supervisory or control purposes, the edge of network nodes need to understand when that SCADA system is online, because for all you know, it could be publishing information to a system that is not online, right? And all of that data is being lost, right? It's not being acted upon. No one is really visualizing that information. So if that's the case, then maybe the edge of network node can then default to storing that information locally until it recognizes that the primary host has rejoined the network, and then it will push that information back. So which means the primary application needs to have a way of also indicating that it is now online and then that it is now offline, which again, I'm going to show you shortly under the behaviors that I'm going to be looking at. So basically, this is the architecture of an MQTT Sparkplug network and all the components that are involved and how they interact with each other. So whenever you're building a Sparkplug system, these are the components you are likely going to be working with. So it's either you're working with an edge of network node, or you're working with a primary host, a SCADA system, or simply a host application or a device that you need to interface with that speaks a legacy protocol. So now let's move on to kind of like showing you a layout of exactly how you could structure your architecture. So for example, here we spoke about how this the root element is for like specifying the encoding, and then the second element is like for specifying the group ID. So here, this is where you could have group of nodes. So you've got the first group of node, the second group of node, and then connected to that group of node, you've got an edge node 1 and edge node 2. Now, edge node 1 here within this group has to be unique, right? So you can't have edge node 1 again here when you name your nodes, right? So again, also it is case sensitive, and also it has to be unique. An edge node has to be unique within a group. And then again here, a group has to be unique here within that root system. Now, if you combine these two edge node and group ID, they form what is called, so basically these two, they form what is called an edge node descriptor, right? So an edge node descriptor is, now if you combine this, the name of this group of nodes and the name of this edge node, it needs to be unique, meaning that you cannot have group of nodes 1 and group of nodes 1 here, and then group of nodes 1 here, and then edge node 1 here. So it needs to be unique, the combination of these two. So whenever you are structuring or allocating the topic representation within your edge of network nodes or within your SCADA systems, you need to take care that you don't put names that are not unique within, first of all, within a group, and then secondly, as a combination of both the group ID and edge node ID. This needs to be unique throughout your Sparkplug network. And then obviously you've got your device ID connected to each edge node. And then for each device, you've got a metric that is being generated per device. So each device could have 1,000 metrics, again, metric 1, metric 2, and a metric could also sit here at the edge node level if your network happens to not have a device sitting behind an edge node. Now, so that's the edge node layout. So let's look at a typical session from the perspective of a primary host application when it is connecting to an MQTT broker. So first of all, the primary host application would connect, will send an MQTT connect message, right? And then it needs to subscribe to the root element, right? So if it subscribes to the root element, to ensure that it receives all messages that are being published, all Sparkplug messages that are being published to this broker, if it subscribes to this root element, it will receive all of this information. So typically, this is the kind of stuff that is handled under the hood, or it will be available for configuration for you, where you can specify that this is what you need to subscribe to from this particular primary application. And then once it has done that, the primary host will then go on to subscribe to its own state. So if you remember from that interface, we've got a way of specifying what is the host ID for each primary host application that a node recognizes. So it means that a primary host application needs to have a topic where it publishes its state. So here, this is where it will publish, for example, host app ID will be the topic to which a primary host will subscribe to and publish to for any edge of network node to understand what is its current status. So after it is connected and subscribed to the root element, it needs to first of all subscribe to its own state, right? And then after that, publish state. So if it is joined the network, it will publish that it is online. So the metric that is contained in this host app ID topic namespace would be the state of that primary host application. So if it is online, that payload would indicate that it is online. So the edge of network node would understand that this is the current state. And then if it is offline, that payload would indicate that this is offline. So again, the edge of network node to understand that my primary host application is now offline. So that's the sequence of events or the operation behavior of a primary host application as it joins an MQTT network node. So this is crucial if you're going to be building your own edge of network applications, right? So maybe you're prototyping on a Raspberry Pi or any device, you're building your Python application, you need to kind of like understand this mechanism flow. But again, all of this is included in the Sparkplug specification, which I certainly recommend you to check out if you find yourself having to build an application, a Sparkplug, MQTT Sparkplug application for, say, an edge of network node device or a host application. You need to check the specification, which you can find on the Eclipse website. So let's look at the how a Sparkplug edge node would typically interact with an MQTT broker. So basically, a Sparkplug edge of network node would send, again, a connect. So a connect really is like the beginning of any MQTT session. After it has done that, it needs to publish, to subscribe to the commands that are coming from the primary host application. It needs to subscribe in case the primary host needs to send it some commands. The edge of network node needs to subscribe to that command. So it can subscribe to commands on behalf of itself, which is the node command, or if it has got some devices that are sitting behind it, it can also subscribe to the primary host to receive commands on behalf of those devices that are sitting behind behind that edge of network node. After it has subscribed to receive the commands, it will then publish path message to the MQTT broker. So basically a path message, again, it is going to be all the metrics that the edge of network node it is going to be publishing. So if it's going to be publishing 100 metrics, temperature, pressure, and all that kind of stuff from many different sensors, it needs to push all of those information with the data types to the MQTT broker to indicate that this is the message that these are the messages that I'm going to be publishing, or these are the metrics that I'm going to be publishing to the network. That informs the primary host application or the SCADA host application to then create that hierarchy, that tree hierarchy that you will then see, for example, maybe within in Ignition SCADA environment, where if a message is pushed, automatically that tree hierarchy is automatically formed. That is coming from the path message, because the host application knows that this particular edge of network node is going to be publishing this type of data, this type of data. So it can then build out that tree structure, which then allows the SCADA engineer who's building that interface to simply just go to that tree structure and see what information is going to be published, and then simply pick it out, drop it onto a canvas or whatever SCADA platform you're using, and then build the visualizations based on that tree structure. So that is why it is important that information is published in that path message. So if that edge of network node disconnects, right, it loses connection, and end depth is published again, so that information would show on the on that tree structure that is created, that has been created by the primary host application, that this information is no longer valid. We no longer have a connection here until that connection is established again. So the edge of network node publishes path messages on behalf of the devices as well. So if it has got devices that are sitting behind it, it can publish path messages on behalf of those devices. So, well, here I've got examples of some payloads that you can see here that have been published. So as you can see here, that's an example of a metric. So as you can see, this is from my good friend Jens, who built this app. So this is the coming from his home automation system here, where we have got the name of the metric called outdoors temperature, and then you've got the data type, which specifies that this metric is a float data type, and then the value of that metric is 0.7. And then here you've got also a humidity. So within each device birth certificate here, you can see that we're specifying that we're going to be pushing temperature and we're going to be pushing humidity, and these are the data types, and these are the current values, and this is this timestamp. So that's a typical birth message coming from a device that will be sent to a broker that you can then visualize from the SCADA system. And then this is the data that then follows after that message is that path message has been published. You can then start to report whenever there is a change. You can then start to report by exception from there. And then here, these are also the device properties. So a metric can also have properties, right? So it cannot only be just the actual data type and the value, but it can also have things like location. If you need to have a property that represents the location, maybe if you want to represent GPS coordinates, you can also put that within a Sparkplug metric and have that represented. So using the data types that Sparkplug metrics allows you to build. So there is a property data type that allows you to build this up. So here we've got a command. So this is an example of a command, again, coming from this Opti22 device, whereby the edge of network node sends these commands because it needs to notify the primary host application that these are the commands that I'm capable of responding to. So for example, this is a command for repath. So this edge of network node is indicating to the host application that I can understand a command called repath, which when the Sparkplug host application, primary host application sends this command, it is instructing the edge of network node to send its path message again, right? So in case that it needs to get that information, maybe it's missing something or something has recently joined the network, it can request that message to be resent. But I'm going to touch up on a bit on exactly how that can also be made to be efficient on the next slide. So again, here there's a command that this up to 22 device understand, which is the current MQTT server. So a Sparkplug primary host can send a command to say, can you give me the current MQTT server that you're connected to? So if maybe you're using two servers for redundancy purposes, it will then say, okay, I'm connected to this specific MQTT server. So as you can see, that's the current value that specifies which MQTT server this particular edge of network node is currently connected to. So what I've been discussing so far is really what is part of the Sparkplug specification, which really falls under this tab here where it says Sparkplug compliant, right? So with Sparkplug compliant, the MQTT broker understands quality of service 0, 1, and 2, and it also understands the concept of last will and testament, right? But there's other concepts that are not part of the original Sparkplug specifications that are crucial to have, which delivered in what is called Sparkplug Aware. So, for example, Hive MQ Broker provides that as an extension that you can put inside your MQTT broker that gives that capability for your broker to be Sparkplug Aware. So, what does it mean to be Sparkplug Aware? It means that when a message, an end death message is published to the MQTT broker, ordinarily that information is not retained, right? If you have to send a message to get that information again whenever you disconnect. But Sparkplug Aware allows these messages, the broker to retain these messages, right? So when these messages are retained in the broker, it means they can then be pushed down to all those who are interested in those messages whenever they reconnect or whenever they rejoin that network. So that is what is called Sparkplug Aware. So a Sparkplug Aware broker must offer these under this topic namespace Sparkplug certificates, where if you request data from this particular topic namespace, you will get all these end death and depath messages that have been retained in the broker. Now, there's also the other issue where a Sparkplug Aware broker may update its last will and testament. So when you first connect to an MQTT network, you send that last will and testament, the timestamp that indicates exactly when that death message was published. So there is no way currently of updating that to say, okay, I need to update to indicate that this is my latest will, right? This is the latest will and testament. So if you publish that will and testament 25 hours ago, that will still reflect as a will of 25 hours ago. But if you want to have a mechanism for updating that will to say, okay, this is the latest will, you are able to do that using a Sparkplug Aware broker or mechanism also, which is really not a must, but a Sparkplug Aware broker may allow you to kind of like provide that functionality. So again, this is all that we have here. I'm really hoping that I could take some of your questions with the remaining few minutes if you have these. And yes, so Thomas, yes, this session is going to be recorded. It's going to be available on YouTube, right under the live tab, so you can find it there. Okay, so if we've got no questions, it seems we've finished right on time. So, I mean, for those of you who haven't yet subscribed on the YouTube channel, you can subscribe so that you can get all these sessions as they come through, and make sure that you switch your notifications on. So thank you so much for joining this session. Really appreciate your presence here. Watch out for some more sessions in the weeks that follow. So we're going to be doing this every other week, every week, in fact. So again, thank you so much. Speak soon.